I am Joe Frankham. I'm a professor of computer science at Utah Tech University, and today I'll be demonstrating and showcasing how to use Docker, just a very brief introduction to Docker and containers. So once you have Docker installed, you can execute the Docker command and you can see a bunch of subcommands that are available to us. I'm certainly not going to cover all these today. I'm just going to cover some of the basics. So the first thing we want to do is let's just run a container. And in another video, I've described what a container is. Here is a very common container that is run. And so to describe what happened there, I issued this command here at the bottom, docker run hello world. And if you read this message, it says the Docker client contacted the Docker daemon, the Docker process. The Docker process pulled the hello world image from Docker Hub. Again, that's on the cloud. The Docker daemon created a new container from that image, which runs the executable that produces the output you're currently reading. And then the Docker daemon streamed that output to the Docker client, which sent it to your terminal. So that's the Docker run command. Again, if I run it again, you can see it didn't have to download at that time. It already had the image downloaded. Remember that a container is based on an image. So let's look at what images I currently have downloaded. If you do Docker images command, here's a bunch of images that I have downloaded, but the hello world image is also downloaded, and that's the one that our container was created off of. Let's remove that image. Hello world. Now it says I can't remove the image because there's a container that's based on it. Well, let's go look at my containers. So the Docker ps command will show us our containers, and there's none, or at least Docker ps shows us our running containers. ps-a shows us all of our containers. So you can see that I have two containers that were based on hello world. Let's run another one. Hello world. There's a third container that's based on hello world. Now you can see that I have three containers, which they're all exited. The status has been, they're completed. They've done what they were designed to do, but they still persist until we remove them. So let's go back. Let's remove our containers, the ones that aren't running. So we can say docker rm, and then we can refer to the name, this random name that was given to them when they ran. So peaceful, whatever that is. So I can hit the tab key to autocomplete. Docker rm awesome something, docker rm. And then let's look at that lists all containers, whether they're running or not. And now you can see that there's no running containers. Let's look at or even stop containers. Docker images, I still have the hello world image that exists. Let's remove it. Docker rmi hello world. And that removes the image. So now I have removed the containers. I've also removed the images that those containers are based on. So let me run it one more time and see what happens. So if I say docker run hello world, it says I can't find the image locally, so I'm going to download it from the cloud, and then it does what the container is supposed to do, and then it exits. So we've looked at a couple of commands. We've looked at docker images, which lists our images that we have installed, and how much memory each of those takes up on my computer. You can see that some can be larger than others. These are a gigabyte, whereas this hello world is only 13 kilobytes, so it's fairly small. We have looked also at the Docker ps command to show our images. That will show images that are running. Docker ps-a shows the images that, all images, regardless of their status, whether they're running or they're exited. We've also looked at docker rm to remove a container, and we've looked at docker rmi to remove an image, and we said hello world, and I'm hitting the tab key there to autocomplete so I don't have to type in those long names. The next thing that it said to do, if we go look at our hello world output, it says try to run something like this, docker run it ubuntu bash. Let's try that one. Docker run -it ubuntu bash. So this one, what it does, Docker run signifies that we're going to run a Docker container. Minus IT says we're going to run an interactive terminal, which is usually what you launch when you're wanting to interact with the underlying container itself. The image that this container should be based on is Ubuntu. And when the image launches, we want it to run the bash process. So you can see here, I'm in the container at this time. It's logged in as root, given this random host name. I'm in the container. And I can do whatever I want to do inside of that container. And then I'm going to exit out of the container, and you can see I'm in a totally different location. So this created a container based on Ubuntu and launched the bash process. Let's go look at our Docker ps-a. So again, this status is exited. A container will only run as long as its main process is running. And as soon as I exited out of the bash terminal, it also exited the container. So yeah, to remove that, I can say docker rm and give it the name that you see there at the end, and it will delete the container. So we've talked about images, we've talked about containers, we've talked about how a container is based on an image. We have also looked at the hello world image that was someone else's pre-created on Docker Hub, and we created an instance of that image. So the next thing, or the last thing I want to show you, is how do we create our own images? And in this directory, I have several different files. Now, when you create a Docker image, it's going to be based on, the whole purpose of using Docker is to host applications. We want our applications to be running inside of a container. So this is a very minimal Python application. We can take a look. app.py imports a few things. Whenever someone visits the URL at the /, it should return hello world. And the app is listing on port 8000. So it's a very minimal Python application, nothing hard about that. The requirements is a file used by Python to figure out what items are needed for this application and installs the appropriate packages. So we want to create our own image. The creation of our own image can be done by using a Docker file. So in this directory, I have several files. App.py is my application. The Docker file contains the instructions that I want to use in order to create my own image. And remember, I will eventually create containers based on this image. README is just a reminder of how I use this directory, and requirements contain the files or the list of libraries needed for my Python application to run. Let's just take a quick look at my app.py file. Again, very simple, minimal Python file that says I want to utilize this library. Whenever someone visits this / in the URL, we want to call this function, which returns hello world, and it's going to be listing on localhost port 8000. So a very basic Python application. If you look at the requirements, so the requirements file just says you need to install Flask. That's used when we're doing like a pip install. And now let's look at my Docker file. So the Docker file contains the instructions on how I want to build my image from which containers will later be deployed. You can see in these uppercase letters, you can see these are words that are have special meaning within our Docker file. And I'm not going to go through every single word that we could put in this Docker file, but I'll go over the ones that are in this Docker file. So from says, when I'm building this image, go grab this other image that someone else has already created that's found on Docker Hub. So my Docker file will go download it if I don't already have it. If I do have it, fine, we'll start with that image as my starting point. Workdir is kind of like a cd command where we're going to change directory into /app, or in other words, the main location of this image, the main launching point for this image or any containers based on this image will be found in the /app directory. The next copy command says, go ahead and copy my requirements.txt from my current working directory into this /app directory. So it should copy that. This next, so copy copies files into our image. Run executes a command at build time. And this is the command that we're going to run, or that we're going to execute at build time. So we're going to run pip3. Again, if you've done any Python programming, you know that pip3 says, go read this requirements file and install these packages into the image from which my container is going to be based on. I then said, copy everything else from my current working directory into /app. And then entry point, when my container launches, it is going to launch the Python 3 command, or use the Python 3 program to run the following command, app.py. That's it. And there's other ways of writing this, and probably others that could have made things a little bit more clear. But these are the basic syntax for building a Docker file, creating a Docker file. Well, once we have our Docker file created, we then need to create our image that's based on the Docker file. The way to do that is we're going to run the docker build command. So docker build says, take what's in the Docker file and process all the instructions and perform those tasks and generate an image for me. I usually put this -t field that says tag the image. So I'll call this one my hello. And the dot at the very end says, look in this directory for my Docker file to read those instructions. I will then hit enter, and hopefully it'll start processing these instructions. Again, it goes and builds. You can see here it does the instructions there, and it says everything is done. Let's look at Docker images. So now we have my hello that was just built. And I may have already had some other images downloaded that it was based on, because that was very quick to build that. So anyway, once my image is built, we're not done. We just have an image, and now I can run containers based on that image. So let's run a container based on that image. Docker run, and then we can say my hello, and let's see what happens. So it looks like it's come up and it's listing at this is what Python is supposed to do. It's supposed to start listing on a particular address, and this is listing at port 8000. Now, because it's consuming my terminal, I can't type any other commands here. Let's kill it and let's run one other flag in my Docker run command. So I'm going to hit Control-C to quit. I'm going to come back up here and I'm going to put -D to run it detached mode, and that will no longer consume my terminal. Docker PS. Now the PS command should work, because this is a running version of my container. It's been up 3 seconds. Let's run Docker PS -A just to review our earlier command. I have an earlier container based on my hello that exited. It's because I typed Control-C to exit out of it. We could remove that, clean it up if we want to. Great. So it's running, says it's running. Docker PS, and I think it's running on localhost 8000. That's what we want to. We want that to be able to work when we're done. Remember, we want to be able to get to this app. Let's take a look. Cat app.py. So we're running at port 8000. Let's stop that container one more time and add one more flag to it. So this is a command we haven't looked at, Docker stop. So we're going to stop this running container. Sometimes it might take a second. And then we'll Docker RM. And then I'm going to come back to my Docker run command, and I'm going to add one more thing to it. So run it in detached mode, but I want to forward port 8000 from inside the container back to my localhost port 8000 so we can access it. Let's run it. Let's look at Docker ps-a. I should only have one container running. Now you can see it is doing some port forwarding. It's taking port 8000 from localhost, forwarding into this container port 8000. So I hope at that point, my curl command will work, and it does. You can see it gave me back hello world, which is all my app is supposed to do. So success. I was able to create a image based on this Docker file. I was able to build the image. I could see my image here in the Docker images command, my hello. I was able then to create a container based on the image. You can see it's still running. And there's just one more thing that I want to show. After we create the image, we might want to share it with others. Now, to do that, we need to push it to Docker Hub, push it to our cloud-based service, Docker Hub. So the last thing that we need to do, that's typical to do with an image after you've created it, is you want to take that image and you want to share it with the world. You want to push it to Docker Hub. So we are going to go back and we're going to run a command, our build command again. And the only change we're making to our build command is we're going to put our Docker Hub username in front of our image name. Now, I haven't shown how to log into Docker Hub, but it's pretty easy. Go to dockerhub.com, create an account, log in, and then you'll have your username. And anyway, with the build command, I'm going to build an image with my username in front of it. Then as I say Docker images, you can see that my hello is here, but also this username, my hello, is here. So after we've done that, it's pretty easy. Then we can do Docker push. You do have to log in here from the command line, which is longer than I want to explain today, but we can push this image to Docker Hub, and then we could log in on Docker Hub when we would see it, and or we could give this image name to other people in our organization or whoever we want to share it with. They can then utilize that image to create their own containers and or images. They could use that in the from line on their Docker file. So they could then make use of this in the from line and base it on my image, and then create their own containers and images based on that. So that's a quick overview of Docker and some of the basic commands of Docker. It takes a while to get used to those and figure out what commands we can use and how to use them, but I encourage you to become familiar with Docker, learn how to use it. It's becoming very popular. There are other add-ons such as Docker Desktop for developers that make integrating and utilizing Docker very easy to do. There's also cloud-based services that will run your images like Elastic Container Service on Amazon. And then there's some even advanced container orchestration tools like Kubernetes. So for developers, for system administrators and operations people, understanding Docker is very important. So thank you for joining me today for this tutorial. I hope you enjoyed it. I hope you will learn how to use Docker. Thank you.